everyone. Great, great. How many of you guys are using AI? I see only few hands. Actually, 100% of you guys are using AI.
It's not me, it's my avatar.
Yeah, so whether you are using a mobile phone or you are driving a Tesla or talking to Alexa, or using Amazon.com, you are using AI. So let me ask a different questions. How many of you guys are building applications with AI? Yeah, I see, few faces. All right, my name is Debu Panda. I'm a senior manager of product management with Amazon Redshift. And with me, I have Murali Narayanaswamy, and he is the principal ML scientist working in the Redshift team. And me and Murali have worked together to build many innovations in Redshift. And we are going to go over about this new feature, how Amazon Q generative SQL is going to make your life better, how it is going to make you more productive by authoring your SQL, your queries with natural language. Okay. So there is a question always, what is generative AI? Generative AI allows you to create content, ideas, conversation, images, videos, and music using, artificial language foundation models. And you probably have heard ChatGPT, that is, a foundation model for generative AI. And generative AI is powered by large language models, that work on, vast amount of data and help you create content. Why customers want to use AI? So when we talk to customers like you, they want to use AI to improve their, customer service or enhance the, customer experiences. They want to improve the employee productivity. They want to optimize their business process. And there are so many use cases you will find with your analytics platform or with your data warehouses that you can use AI to improve, your how to gain insight on your data. Amazon, I don't need to talk about this slide, but it has been leading innovations in machine learning and AI, and it is in Amazon's DNA. So I don't need to read this slide. You guys know about all these things. So when we talk to customers, that we have different personas that work with Redshift. We have developers and the data engineers who want to build analytics applications, and they want to use AI ML with their application. We have, data scientists and data analysts, who want to improve their productivity or you want to get better insight from their data using machine learning model, and they want to get insights faster. Then we have administrators, who want to make the management of their serverless or the data warehouse simpler by using machine learning. So if you look at, now I'm going to give a recap of different ML innovations that I've been doing in Redshift in the past several years. So in 2019, we introduced a auto WLM and auto scaling, which is driven by machine learning. Then we introduced in Redshift ML, and actually Murali and I worked together on that project, that allows you to create machine learning model using SQL. So you do not have to be a machine learning specialist to create machine learning model with Redshift ML. You can just use a SQL statement, and I'm going to show some example, how can you create machine learning model with Redshift ML. But again, in 2021, we introduced serverless that also leverages a lot of machine learning capability. Last year, we introduced the auto MV and auto refresh. Auto MVs are nothing but when your customers are running repetitive queries, like 300 people are running the same queries, joining like 5 different tables. What auto MV does is that it automatically creates MVs or materialized views for you, looking at your query patterns. Then this year at re:Invent, we introduced 2 features. One is the next generation of AI scaling and optimizations that allows the serverless work group or serverless endpoint to dynamically size based on your workload and giving you better performance and reduce cost. And then the generative AI support that couple of features that we announced. One is the Amazon Q for generative SQL. The other one is that providing you the ability to invoke jumpstart foundation models or LLM models directly from SQL. So I'm going to go a little bit more details into that. So AI for administrators. So as you know, we have been doing a lot of autonomics, in the Redshift data warehouse. So we have automatic, sort key and distribution key. You do not have to worry about creating those. We have auto vacuum and analyze. You have auto smart defaults. Then we introduce some feature called MDDL. Automatic MVs. So we have been doing a lot of automation, and all these are driven by machine learning models internally. And then we have Redshift Advisor that look at your query patterns and then use up your clusters and recommends whether you should pause your cluster or you should add a sort key or dist key. So all those things are driven by internally by machine learning model. Then we, as I outlined earlier, that we introduced this feature earlier this week. This is a preview, and you can sign up for this preview yourself if you are using serverless. That builds more intelligence into the serverless infrastructure, Redshift serverless, that allows you, like if you remember, if you have used serverless earlier, then you always have to specify a base unit or base RPU. So let's say you start with base RPU at 32, and then based on your load, it goes up and it may auto scale. But like let's say there is no user activity in your serverless endpoint, and it pauses, and then next time you run your queries, again it starts as 32. Okay? So what this features allows you is to have that dynamic compute. That means it's real dynamic based on that. Based on your load, it automatically changes your base. There is no need for you to worry about setting the right base RPU. And it always, optimizes based on your workload, your query pattern, and then improves your query. So there is no manual action required, except, for the preview, you have to sign up that I want to use, this feature. And that was a few things we have done for the for the administrator. For developers, AWS provides a full stack of services. Whether it is SageMaker provides a complete set of services for either building your no-code ML model using Canvas. It provides all those things. I do not have time to cover all these things, but AWS provides a complete stack for building and operating ML models at scale. And then it also provides all the ML infrastructures, like we have different even chips, AWS Inferentia and Titanium for specifically for machine learning purposes. And then we introduce, Sage Bedrock, which also, is our platform for, building generative AI application. So if you look at, this slide, what it shows is that AWS provides a complete, foundation for data and AI. So if you look at, there are different data sources you might have, whether it's coming from IoT devices or apps or logs or the different third-party. And then we have, different streaming ingestions product like either Kinesis or MSK. And also you can, bring this data, let's say into your OLTP databases. And then these data you can either zero ETL into a Redshift, and then we already have support for streaming ingestion that bring your data and then you can use it right when it is being created at the source. And then we have on the right, if you have, there is different product to consume that data, whether people are consuming using tools like QuickSight, or if you want to build your machine learning models, then use different platforms that we have. So coming to the developers, what we heard from many customers is that, they have different kind of data in their, Redshift tables, and they want to use, LLM models directly on those data. Like for example, let's say you have a table which has, customer feedback captured, and it is in Redshift, Redshift table. And then what customers are doing is that they want to find out how is the customer sentiment from the last event, or like, or whatever, whenever they're getting this, customer survey comments. So what they were doing is they're exporting the data and running in an external machine learning platform or a product like Comprehend to find the sentiments. So what we are allowing customers to do now is that you can use Redshift ML to create a machine learning model pointing to a Jumpstart LLM model, And this is a SQL statement that you use, like create my model, from LLM model. And it basically returns a support or a data type. And then, that your users will be run those SQL directly in Redshift. That means basically when you run the prediction, like, that function, my LLM model is the name of the function, that actually is available to your users as a user-defined function. And then your users can run that directly in their dashboard or any other query. So you'll be able to easily find out, for example, customer sentiment by directly calling a foundation model from SQL. So when we talk to customers about the challenges their data analysts face, is that first time what we hear is that in some of the organizations there is a lot of churn of the data analysts. That means data analysts come, work for 3 months or 4 months and then leave, and there is a new person come, for example. And whenever a new person comes, what happens is that in many of our organizations, the schemas are complex, different kind of schema, maybe it's completely different kind of business or industry type. So it takes a lot of time to onboard. Although they know they are expert in SQL, it takes time to understand the complex schema. And then what I hear from customers that, it's a little bit boring, repetitive SQL, the same SQL they need to run, it becomes boring. And then, when they run into some issues, it becomes problematic for debugging. And then many of these data analysts, they want to use, machine learning for get better insight from their data, they are not able to do it because they don't know Python or R or any other machine learning technology. So, couple of years back, or almost going to be 3 years now, we introduced Redshift ML that allows customers to train their model using SQL. So, assume that you don't know anything about machine learning. You have no clue, but you want to use this for prediction whether this customer is going to churn or not. Or I want to calculate how much my revenue is going to be after 3 months. Or I want to find out how much whether my customer lifetime value for this customer is going to be. So this kind of problems, many people use Excel and then do this kind of analysis. It takes a long time. What Redshift ML does is that whenever you do you can just use a create model command, specify your training data that you want to train on. So that's and then you tell which column you want to predict. Okay, that's the target column, and just run that model. The model actually runs multiple experiments. It finds the right problem type, whether it's a regression or or classification problem, and once it finds the best model that suits your use case, then the model gets installed as a user-defined function. Then after that, your users can run that and get predictions quickly. So we have several customers who use, like thousands of customers who use Redshift ML, making 80 billion plus predictions per week. And then we have 2 customers like JobCase and Magellan RX who are using in a very interesting ways. Like JobCase does more than 1 billion predictions every day for making job recommendations to the job seekers in their site. And Magellan RX uses Redshift ML for medical therapeutic conditions predictions. This is one thing that we hear from customer is that we need our users need a good tool for data analysis. So we have a tool called Amazon Query Editor, which is a web-based tool that users can log in directly using their single sign-on and run their queries using SQL, and do their data analysis. It also provides ability to create your notebook using just SQL and markdowns, do the visualizations, share with other users. It does this version control automatically. So, I'll just do a quick demo of the query editor. So if you see here, I am connecting to a Redshift cluster. So I have multiple clusters. You can enable, disable, based on your IAM policies. You can just limit the different clusters. Once I connect to a clusters, I can actually automatically browse my Glue catalog, like this AWS data catalog, or my different databases. So here I have multiple databases, and some of them are Redshift data sharing databases. And then I can expand and look at my catalog, look at different schemas, and where I have tables, user-defined functions and stored procedures, views, all the different objects. And then I can select a specific table and run queries, or like it provides ability for syntax error checking. It provides ability to auto completion that I'm going to show quickly. But the more interesting thing is that many customers, they want to provide their data analyst, for in their own personal space to create tables and load data. It actually provides you ability to load data and create tables using visual wizards directly. So if you see here, I have create different. You can create with visual wizard like databases or schema, or create load data. So you can load data either from your desktop or from your S3 bucket. So I'm going to quickly demo how to load data from your desktop. and use the auto inferencing capability to, create the schema table as well as, load data. So if I will select one a CSV file, the account history, CSV file, then I am going to select, my which database I want to load into. So I selected, these are the different parameters that my delimiter is a comma, and then I select, I want to create a new table for this one. So I'm going to create a new table. I specified in this database, I'm going to specify a schema, and I'm going to use the demo schema, give a table name. And if you see this basically automatically read the, the table header and selected the different data type. If you want to change a specific data type, you can change it and there, and then, go from there. So this is a precursor to the query editor because the queue capability is built inside the query editor. So create the table and then you can just load the data after that. So this is how easy is for you to, create a table, load data and then run queries. The other interesting capability that we have is something called SQL notebook. So what I'm going to show you a SQL notebook, that I have already created, but you can create your own notebook, organize in different folders like Google folders. You have, and organize this folder. Let me open my a sales notebook that has right now, a couple of cells. A notebook can have multiple, cells. So one is the annotations or the markdown cell. So you can use the standard markdowns for creating a header if you want to, or a description for your cell. So this is a header for my notebook, and then you have multiple, SQL statement or multiple markdown. So I have, if you see here, basically as you loaded, because I already had created a, big chart for this specific SQL. What I'm going to do is that I'm going to run you can run all the SQL together or run only one. So I'll just run this SQL and I'll show you how easy is to, create a chart from here. So if you see this data, so I can actually export this data in CSV or JSON if I want to share with someone, or click on chart. So and then we provide different kind of visualizations, and you can provide actually give your table header, column header, all this kind of stuff before. So now I have my notebook. I want to share with another user. I can actually easily share this by clicking on share, and all this are automatically versioned. So, but if you want to create a specific version, you can actually save a version of the notebook. So with that, what I'm going to do is that go to the next thing is what is generative SQL. Okay, generative SQL is as I've been telling you, like it's kind of improves your productivity by allowing you guys to express your queries or author your queries in natural language or plain English. So you and these are actually personalized. That means your personalized. It's not like, for example, any SQL that it generates. It's personalized to your schema, to your context. It's based on your query history. It is conversational. That means it's not just one like random. It generates and then you can work on to improve your query. For example, you asked a question like, what was my top venue, and it is going to give you a SQL, and maybe I think it when it's generated the SQL, it considered in total revenue for identifying the top venue. You can ask, actually I meant by ticket sales, so that is going to limit to ticket sales. Change your query. So it is conversational, and it is accurate because it uses a lot of your data, your context. That means what database you are using in context. If you have column definition or any definition or table definition, You use that. If you are using, let's say you have created your, foreign key relationship. Although Redshift doesn't enforce the foreign key relationship, we actually use that to create the join conditions. It is, and then when it generates the SQL, as when Murali is going to demonstrate, it is not just for one table. It can join 3-4 tables, to generate your SQL. And it is secure. That means basically we do not bypass the security for generating the SQL or running the SQL. So when you get the SQL and you try to run the SQL, all the Redshift security, RLS, CLS, data masking, everything is going to be enforced. The other thing is that we never send this data, whatever your table definition, your anything, to the foundation model for training. It is used, is just for building inferences using RAG. So I think Murali is going to go more details how these things work. So if you, there are multiple benefits for the Q generative SQL. First thing is that it increases productivity. That means if you are lazy, I am always lazy. So if you want to write a SQL, you can just ask that in English and it will generate. Because if they say, you have to join 3 tables, you have to put like first table, alias, all the different tables, if you are not writing every day like me, then, it actually makes it much easier. So it is going to make you, improve your productivity. Second thing is that it helps you get started fast. That means basically if there is a data analyst is coming in, he doesn't understand the schema that well. So what we do is that because it can actually leverage the schemas as well as the previous queries, the query history, it can help you get started fast. Then again, it is provides secure access to your data. There is no bypass of any secure. And then as you run more and more SQL, it improves the accuracy based on your data and on the recommendations. And when you get a recommendation, you can actually do not have to accept the recommendation. You can say, give me more, and then let's say you reject the first recommendation. Next time whenever it generates, is not going to give that recommendation because you rejected it. So it is, you're giving direct feedback to generative SQL. So now I invite, Murali to come and go over more details, how these things work and do demo of, the generative SQL capability. Thanks, Murali.
Yep.
Yeah.
Thanks. Yeah. So I definitely cannot match Ibu's energy. So I'm going to try. To at least go fast. Right? So basically, as Debu pointed out, the goal of whatever we're doing here for Q is to give you personalized SQL recommendations that are context aware, specific to your database, but in being safe and secure at the same time. And what we mean particularly by secure is that none of your data, content, tables, etc. are used to train any foundational model. So, all the data governance, everything, you don't have to worry about that if you're using Q. But at the same time, you actually want to make these things useful. So what I'll try to talk about is how we do it, right, while being secure. Okay? So to recap what Debu was talking about, right, the big problem we heard from customers while we were building this is that, once the tables in their database is more than, say, 10, a few tens, not to mention hundreds, it's very hard for anyone to remember, what was the join key exactly, how should I join these 2 tables, what's the filter conditions, what makes sense, this is really, really hard. And this gets even harder if you get someone new and just plonk them in front of Redshift and say, tell me the sales for the last month, right? And this is a huge time sink for our customers, and we want to make this faster. And the second thing we want to allow customers to do is to essentially create more and more complex SQL, but faster. So as Debu says, he doesn't write much SQL, neither do I anymore. So, I really struggle to remember how to build these large compositional queries, right? Where you take a query, put it inside another one, and then try to get a bigger and bigger answer. So the conversational capabilities of Q, which I'll demonstrate, make these things much easier. Okay. So we keep talking about this thing called personalized SQL, right? So what exactly do I mean? I'll show you like 3 or 4 examples before getting into the actual demos. So the first kind of example, these are some queries from a standard SQL thing called Spider and another one called Bird. You can look them up, but these are just standard SQL questions. So now suppose you had a question like this, right? Count the number of schools in Alameda County. And you just went to like an LLM and gave it this exact question. Right? You would get what I would call the natural output, which is a query, which kind of makes sense, and has all the stuff in it. But if you actually go back to that benchmark or those tests and look at the tables in there, this query does not execute. Because it does not know the actual schema, the table names, and the column names that this database has. So if you go and do this in Q, once you have loaded up this data set, you'll get this actually reasonably a bit more complicated query, but the interesting thing is that it knew that it was num tst takr, right? Instead of num underscore test takers, which may have been better even, right? It knew which tables to go look into and so on. And this is what we mean by personalized to your database tables and schema. So Q does this, right? We can go to another example. So let's say this is, again, another question from a different database in the same benchmark. Right? And you go and ask this question, and I've given it the schema now, right? And it does something, and this is a very good query. It's fairly complicated, and it makes almost perfect sense. But you go run this again, and the answer turns out to be 0. Right? Now, why is this? Well, if you go and look at the historical queries that the customer has used, you will figure out that actually country, right? They're not actually giving the name of the country, but the code, which is in this case CZE. And the way you figure this out, if you don't look at data, which we do not, is to look at least some of the past queries, try to figure out the pattern that we are using country codes and try it. And this is what we mean by personalized to your data without training on your data, without looking at your data, right? The third kind of thing, another example is, you have this another question, and you get some natural input. Now, this could work, but when you do try to run it, you get this error, right? And this error is basically, for SQL experts here, is, there is an ambiguous term in the select. So what you can do is you can actually just give this error back to Q if you want, and we do this automatically sometimes as well. And once you do this, you get an answer that again works. So as a result of this, both you talking back to Q and us automatically doing this in the background, the results get personalized to your data warehouse, which is Redshift. So now we start understanding Redshift syntax and so on. Okay? So now we get to the kind of recorded demos version of this. So these things, this was launched yesterday, so you can go and actually try it out. But I have learned, to my regret, never do a live demo, so I'm not going to do one. So this is really, really easy to enable, but this enablement has to be done by the administrator. And once it's done by the administrator, it's available to all users in the query editor, which Debu showed. So it's very easy. So how do you do it? You see this settings, or at the bottom left, the gear icon, right? And you just say enable generative SQL and save it. Once you've done that, the purple button is now available, and you have this chat window on the side where you can start asking questions. The other interesting thing about Query Editor is that we also have this ability to load up a few test databases. So I'm going to load one of them called Ticket, okay, and I'm going to run the future examples on that, just so that it's something you could also test out later on. Okay? So once you do load this thing, you can start trying out this personalized SQL. But just to show you again what I mean by personalized, I'm actually going to run the first query and give you an example that doesn't work. Okay? So like suppose I have this whole thing set up. I have my generative SQL thing on the side. And we have some quick examples. But what I do is I go and connect to a different database called dev. Now, this database does not have any of these tables, does not have any of these things. So when you go and try to actually create a query here, right, you're going to get one that does it. Look, again, it's a reasonable query. You can insert it into your notebook. You can execute it. But it's not going to work, right? Because these are not tables that exist in dev. We put them somewhere else, right? I did want to show this because this is like a very common mistake because we don't look across your tables. Again, we keep a very careful eye on all the permission boundaries. So if you are connected to a specific database, your queries only work on that database. Right? So what did we actually want? So we actually wanted this query on the left. So now I go back, I check that I'm connected to the right cluster and the right database. Right? I see that I have ticket there with all the right tables. And now if I go and ask, any one of these are questions we have selected that work on ticket, but you would try different ones on your database, of course. And you get a query. Now, the nice thing about the way it's integrated is there's a nice button there, add to notebook, just puts it into the notebook. Then you run the query, and this time, you'll get an answer that's reasonable. And as Debu showed, you can always chart these answers. You can do bar charts, whatever you want, and get your stuff good. So the next thing that we said about Q is that it's conversational, and the whole thing is personalized to your conversation. So what does that mean? Right? So we had this at the end of the previous question. We had a query. And then now we can now try to dive deeper by just asking, right? So now you can ask, which are the top 3 instead. Now, note that you don't have to repeat your previous question. You don't have to repeat the previous query. All this is in the context of the LLM, right, and our Q algorithms. So now you get a query that gave you the 3. But you can go further, right? Now, this is where the compositional stuff comes in. Now you want to ask a query that uses this bigger query, the smaller query inside it. And to be honest, this query is beyond my SQL understanding, the one that's going to come out now, right? So this is a fairly large query, and what it's done is, it's put the select inside, and then, it's done all the right stuff. This would take me 15 minutes with a lot of searching online, and even then I may not have got this right. So this is the kind of stuff that Q is supposed to help speed up, right? And you get it, and unsurprisingly, most of the popular venues are actually in New York. Right? And what's interesting is the query has all the table names, the schema names, everything in there. And the other thing that conversational things allows you to do is personalize it to your data domain. So if there is some business knowledge that only you have, right? When Q gives you an answer that you don't like, right? You go and ask it for more details or fix it or so on. So for example, you can go, what's the total sales in dollars or whatever it is, right? So far, we have not assumed that the customer didn't even have to know the schema, everything. Everything has worked so far just in plain English. But suppose you get a query and you don't like something, right? You want you don't think that price paid is actually in dollars. You know this, but the queue does not, right? You can just say, and the interesting thing here is this works with spelling errors, it works with lots of mistakes. But if you say, okay, this is not the one, it'll give you a different query by trying to find, quantity sold times, the price of the ticket, which is also a reasonable approximation for dollars. Again, as Debu said, this is joining across many, many tables. It's finding the right conditions, and in the end, it's still giving you a query that kind of works. Right? So this, again, would have taken a person a reasonable amount of time. Now, one thing I do want to say, which is going to be important later, is, so I'm logged in as a user 1 right now, right? So later, I'll show you how by sharing the query history, you don't have to tell this queue the same thing again when you go and log in as user 2. So now user 2 is like a new user and so on. So another way that Q is kind of personalized to your database is that suppose you kind of write a query, or this is actually a query from a slightly different dialect. So this may have worked on a non-Redshift cluster, for example. But suppose you have this query, right? And this is what you want to do. So you want to add row numbers based on the quantity sold descending. So you start writing your query and so on, but you get some error. To be honest, this error is reasonably hard to understand. Like, I have no clue why this is the error, because that's not actually the mistake. So what you can do is you can just copy this question down and ask Q, how do I fix this query, right? So Q will go away and try to give you a query that would actually work on your schema. Again, note it took sales and put ticket.sales, because you need to be connected to the right schema for these kind of queries to execute, right? So it does all this. And then, since it's in my demo, it's going to work. So you get, row numbers added appropriately. So this is the kind of stuff that Q helps increase productivity for our customers. The other thing, in addition to security of your data and personalization, is we also want to make sure everything here is safe. So what this means is basically, let's say, suppose you go in and ask a unreasonable question. Let's say, delete table sales, right? So Q is still going to give you an answer, right? Because it's an easy query, to be honest, right? But what we do make sure is that we always warn, saying that somewhere in this query you are modifying some tables or something in your database, and make sure that you want to do this. Now, since my demo is going to continue, I'm not going to delete the sales table. But the other thing I did want to point out is, so we also always make sure that we respect all permissions of the user logged into the query editor, right? So what that means is, let me take a simpler example, which is not going to delete anything. So here, now we are logged in as user 2, right? So this is a user, not the administrator, and he wants to create a query to select 5 random rows and insert them back, right? So this is a reasonable thing to maybe do. But again, we do raise the warning, first of all, but maybe the user wants to go ahead anyway, right? And then they try to run the query, okay? However, if you remember in the beginning of the thing, the administrator was the one who created those tables, the ticket schema. So user 2 does not have these permissions. So Redshift will immediately prevent it. So none of the protections of Redshift go away, and everything is as secure and safe as it was before. So now I'll go into a couple of tips on how to make this thing more and more useful to you as you deploy it across your organization. Okay. The first thing that we allow you to do is share the queries to a new user. So suppose a new user comes into your company. They obviously do not have any query history, so Q cannot figure out which are the right tables, how to join them all the time. It's still quite powerful, but it's not as good. So we have this command where you can which is a standard Redshift command. It's in the documentation and so on, which basically now allows user 2 to see the query history of other users. And as a result, Q can now use it. So again, Q never breaks any permission boundary of Redshift. Okay? So once you do this, now I log back in as user 2. And again, query editor, So query editor makes this quite easy. You can just change the database username and password. Right? And now I will be logged in as user 2. So I do want to say this, none of this demo so far has been sped up, and neither has this. So here I know I have a minute extra. But so now the user 2 can go ask now what's going to be a fairly complicated question, right? Now, what's interesting is Q will remember that the last time you told it not to use price paid for user 1 because it has access to the user queries. And now it's going to give you a query that does not use price paid, but actually multiplies the numbers again. Right? Now, sharing query history is a double-edged sword. So if you share the query history of all the wrong queries, Q is going to get messed up. So this one needs to be kind of done carefully, and we're going to provide more options for you to selectively add queries that have been vetted in certain ways to the history and improve performance. Right? Again, this query worked perfectly well. It's a fairly complicated query. It knew from the query history that states were TN, not Tennessee, the whole name. And again, fairly complicated query. Okay. The other kind of tip is that none of the stuff is perfect. You do get queries that don't work. So here, I kind of made some changes so that the first query doesn't work, but this query usually works. So we take a query, and then let's say we get an answer. Right? Again, it's an almost perfect query in this case, but we add it to the notebook, we run it, and then we get an error. Now maybe I don't want to go search for how to debug this error or whatever it is. It looks fairly actually it's not a very complicated error, but you paste it back and just prompt Q with it, and now it gives you a new query, and this query tries to fix that error. Right? And you have the whole history of the markdown saying how did you end up with this query and so on. So you execute, and then now you get the right answer that you should have got in the first place. Okay, so just to kind of wrap up, some of the tips and tricks is whenever you can, be as specific as you can. So if you do know the table name and column names, and they are badly named, use the bad names. It's fine, right? That's better than trying to get Q to guess, right? It's always better if you already know which part of the database, which schema you're actually interested in, just add it to the search path. This is a Redshift SQL command. So this allows the queries to work even if the schema names are not up. And the most important thing is, be ready to iterate. And this just makes you much, much faster. So ask follow-up questions and build up queries slowly one by one. Ask back errors and why they didn't work, and then things get better. Right? So for the last bit, I'll hand it back to Debu to wrap up, and then we'll take questions.
Thanks, Murali. Did you guys like the demo? So you guys can try this yourself. This is preview, and there is 0 cost during the preview. So you do not have to incur any cost. You can run as much as you can with your own data, and that's what we want. You try this out with your own data, own schemas, and that will help us, and then give us feedback if it is not working. That will help us improve. It is available for preview in 2 regions, US East 1 and US West 2, that is the Oregon region and IAD region. So we have 2 regions, and then if you haven't tried serverless, you can actually try serverless. For we give you $300 credit for trying out serverless. So try it yourself. If you want to try this together, you can try this together. The Q generative SQL is available for both your provision clusters and serverless. So you just have to use query editor. And thanks everyone for coming. And then we have more resources available. As you see, there are books available. There are Amazon Redshift definitive guide. And then I want to also add a sales blog for my book. They are serverless machine learning with Redshift ML. So anyway, thanks.